Hi all, today we are going to see about the lecture series on Unit 2, Unit 4, 2 in Design and Analysis of Algorithm subject. So the Unit 2 is about brute force method and divide and conquer. What do you mean by brute force method is exploring all the possibilities to solve the problem, and divide and conquer means we are going to divide the problems into sub-problems to solve the sub-problems and then combine or merge the solution to reach out the. So the next topic in brute force technique is about knapsack problem. So knapsack problem is nothing but we are given with a bag of maximum capacity it can carry, and we are given with the values and weights of that particular items. We have to identify the most valuable subset of that values which can be carried with that knapsack. Okay, so this is the knapsack problem. So we are given with n items of known weights w1, w2 up to wn, and values of that corresponding weights are value v1, v2 up to vn, and a knapsack of capacity w, and we are going to find the most valuable subset of the items that fit into the knapsack. So these consider this as the knapsack. We are going to fill these items into this knapsack and we are going to find the maximum valuable subset. Okay, this is the problem. So we are going to consider since it is a brute force method, we are going to try out all the possibilities. So make a tabular column like this. So we are considering subset, total weight and total value. The first subset will be null subset. We are not going to consider any of the items into the knapsack, so it is null. The total weight is 0 and the total value is 0. So given knapsack capacity W is equal to 10, the knapsack can hold only the weight of 10. It cannot exceed the capacity of the knapsack. The items 1 weight is 7, value is 42. The item 2's weight is 3, value is 12. The item 3's weight is 4 and value is 40. The items 4 weight is 5 and value is 25. Now consider the next subset. The next subset will be 1. That is, we are going to consider only one item, that is the first item into the knapsack. The total weight of the knapsack becomes 7 since the weight of the total item 1 is 7. The total value is 42. The value of item 1 alone. So exactly. So the next item we are going to consider into the knapsack is 2 alone. We are going to consider alone elements and with the combined probabilities also. Okay, first we are considering 1 alone, then 2 alone. The corresponding weight and value are 3 and 12. The next subset is 3 and corresponding weight are 4 and 40. The next subset we are going to consider is item 4 into the knapsack and its weight and value is 5, 25. Next we'll try out in combos. Next we are going to combine 1 and 2. So first and second element we are going to consider into the knapsack. So the total weight of first item is 7 and weight of second item is 3. So the total is 10 and the value is 54. So next we are considering item 1 and 3. So weight of item 1 is 7 and item 3 is 4. So 11, total weight becomes 11, which doesn't fit into the knapsack since our knapsack capacity is only 10. So that doesn't fit into the knapsack, so the solution is not possible. So again, the subset 1, 4 also not possible since it exceeds the capacity of the knapsack. Next we are considering 2 and 3 items alone. So the total weight is 7 and the total value is 52. Next we are going to consider 2, 4, that is item 2 and item 4. Total weight is 8 and the total value is 37. So next that item 3, 4, the total weight is 9 and value is 65. Now consider item 1, 2, 3. The total weight is 14, so not be feasible. The item 2, 3, 4, total weight is 12, not feasible. The item 1, 2, 4, total weight is 15 since it is not possible. Next item 1, 3, 4, its total weight is also 16, not feasible. So we are considering 1, 2, 3, 4, all the 4 items into the knapsack. The total weight is 19. Since all these last 5 columns exceed the knapsack capacity, we are not going to consider that items. So the most valuable subset, Since it is a knapsack problem, we have to find the maximum valued subset. The most valuable subset is this 3, 4 with the total weight of 9 and total value 65. When compared with all these other values, 65 is maximum and the total weight is 9, which doesn't exceeds the our capacity, knapsack capacity. So this is our ultimate solution. So the most valuable subset is item 3 and item 4 with the total weight 9 and total value 65. So the analysis of this problem is problem size depends upon the total number of item. So the basic operation is the considering the items and making the total weight and considering whether the solution is feasible or not. Next, the count for basic operation. So number of subsets is equal to 2 power 1. For example, when n is equal to 4, 16 possible subsets are available. But when n exceeds, this brute force technique goes beyond the expected level. When our n is equal to 5, we have to try out 32 possible subset, and think about what n gets 10 and comment your answers.